Hello and welcome to another video. In this video I'll be going through mock set 4 paper 1. This is the non-calculator paper and this is for the EDEXCEL GCSE higher tier. So you won't be needing a calculator, but you will be needing a ruler, protractor and a compass, as well as a pen and pencil, etc. So always make sure you're bringing that equipment into your non-calculator exam. Okay, so let's get started on question 1. Question 1 says, write 136 as a product of its prime factors. So you could start with a factor tree. So just start by dividing 136 by whatever you think goes into it. I have a feeling that 8 is going to go into 136 because I know 8 goes into 120. So 8 times 15 is 120. 8 times 10 is 80. 8 times 5 is 40. So therefore 8 times 17 is going to be 136, and I know that 17 is a prime number and 8 is 2 cubed. So there's my factor tree down to its prime factors. So therefore 136 is going to equal 2 cubed times 17. That was question 1 for 3 marks. Question 2 says a biased spinner can land on red, on blue, on green or on yellow. John is going to spin the spinner. The table shows each of the probabilities that the spinner will land on red, on blue, or on green. So here are the colors and the probabilities, and it says part A, complete the table. So all of the probabilities need to add up to 1. So if we add up these, 0.25 plus 0.15, that's 0.4, plus 0.2 is 0.6. So to get to 1, we have a remainder of 0.4 or 40%. Perhaps we should add some working out in there. They always like to see working out. And just in case I've made some kind of error, it helps to get some marks. So this is 0.6, so 1 take 0.6 was 0.4. Okay, so there should be 2 marks. Part B says Haley's going to spin the spinner 60 times. Work out an estimate for the number of times the spinner will land on red. Okay, so the probability of red was 0.2. If she's spinning it 60 times, we'd estimate the number of times it lands on red would be 60 times 0.2. This is like 60 divided by 10 times 2. So 6 times 2, which is 12. So my answer there would be 12 times. And that was question 2 for 4 marks. Question 3 says an empty tank is a cylinder of height 5 meters. Water is pouring into the tank at a constant rate. It takes 4 minutes to fill the tank completely with water. Malcolm draws this graph to show the depth of water in the tank as water is poured into the tank. Okay, and the question says write down 2 things wrong with this graph. Okay, so here we have the tank. We're pouring water in at a constant rate. So therefore this line should be a straight line. It should be increasing, at the same rate for the entire 4 minutes. Also, this graph should end at 4, 5, not 5, 4. Okay, so they're the 2 things I'm going to write down. Okay, so the graph should be a straight line as it's filled at a constant rate. And the second one, the graph should end at 4, 5, not 5, 4. So that was question 3 for 2 marks. Question 4 gives us a diagram with 2 triangles and it says describe fully the single transformation that maps triangle A onto triangle B. Okay, so A has been turned 90 degrees to get to B. So I feel like this is going to be a rotation around some point. So we need to be able to identify what point it's been rotated around, and it's going to be anti-clockwise. So you can see there, if I turn that triangle around some point, it's going to get to B. So we need to find a point equal distance from B and A. So if we pick, say, this corner, let's see if we can find a point that's equal distance. So if I go across 4 and 2 down to get to -2, -1, and then I go up 4 and across 2, I'd get to this corner, this same corner of B. So you can always use tracing paper to help with these transformation questions, but hopefully you can see if I rotated this triangle 90 degrees anti-clockwise around -2, -1, I'd get to B. Okay, so all we need to say is it's a 90-degree rotation anti-clockwise around or about -2, -1. And those 4 details should get you that full 2 marks there. Question 5 says, this accurate diagram shows 3 points A, B, and C. Region R contains all the points that are less than 4 centimeters from each of the points A and C and nearer to point B than to point A. Show by shading the region R. Okay, so we need less than 4 centimeters from each point A and C and nearer to point B than to point A. So hopefully you can see that you'll need a compass and a ruler for this question. So the first thing you could do is to draw 2 circles around A and C with a radius of 4 centimeters. So I'm not going to be able to actually do this on my computer. I don't have an app or a ruler to be able to show that, but I can try to describe how it should look in general. So this should be over here. So imagine this is a circle of 4 centimeters, and you'll need a similar one around C. Okay, so those areas in there are going to be 4 centimeters from A and C. And we also needed it to be nearer to B than A. So we need a line that's in between A and B, which is halfway between A and B. To do that, you can draw another circle of equal radius around B. So you could use that same 4 centimeter radius and draw that around B. So this is all with your compass. And the line of equal distance between A and B will be a straight line through where these 2 circles cut each other. So if you got your ruler and lined it up with where those 2 circles intersect, it should be a straight line going through those 2 intersection points. So again, I'm having trouble on this app, but something like that, and it'll go out here as well. That should be halfway between A and B. And we needed the area to be closer to B than A. So it's going to be somewhere on this side of that straight line. And also it needs to be within 4 centimeters of A and within 4 centimeters of C. Now the only region that satisfies all of those criteria is this one in here. So even though I haven't got a compass and these measurements are probably wrong, your diagram should look similar to this with this region in here shaded, and that would be R. So just double check those conditions, less than 4 centimeters from each point, which is those circles in those circles, and nearer to point B than point A. So that would be R in there. And that was question 5 for 3 marks. Question 6 says each student at a college is going to be given a notebook. The color of each notebook will be red or blue or green or orange. Bill takes a sample of 50 of the students at the college. He asks each of these students what color of notebook they want. The table gives Bill's results. So we have 18 red, 16 blue, 10 green, and 6 orange. There are 3,000 students at the college. Work out how many red notebooks Bill should buy for part A. Okay, so we could work out the proportion of red in the sample, which would be 18 over 50. And then multiply that by 3,000. And then we need to work that out. So let's see. I would start by cancelling maybe those zeros. And then 300 divided by 5, that's 60. 60 times 5 is 300. So then I'm doing 18 times 60. And then 6 times 18, that's 60. Plus 48, 108. So that's going to be 1080. So that's my answer for part A. Part B says write down one assumption that you made in answering part A. Explain how your answer would be affected if this assumption were not true. Okay, so we assumed that this proportion was representative of the proportion of the 3,000 students. So it might be different, and therefore the number of notebooks we would need would be different. So I'm going to try to summarize that in a couple of sentences. So the proportion, so assume the proportion of students in the sample is representative of the proportion for all students. If not true, the number of red notebooks needed would be different. Okay, so that was question 6 for 3 marks. Question 7 says the plan and side elevation of a solid prism are shown on the grid. On the grid, draw the front elevation of the prism from the direction of the arrow. Okay, so this is from the side and this is from the top. So the plan view means from above, and we need from the front. Okay, so we know it's too wide. because we can see from the top that it's too wide. And we can see from the side elevation it's 5 units high. So we need to go up 5, and it's going to be a rectangle, and then we need to draw in some lines to represent these angles here. So we've got one line 2 units up, and then this slope starts 1 unit above that. So we need a line there. And then this angle is on the top, so we don't need to draw another line. So your front elevation should look like that. That was question 7 for 2 marks. Question 8 says cars are made in a factory for 24 hours every day. In the factory, a car is made every 209 seconds. Work out an estimate for the number of cars made in the factory in 1 year. You must show how you get your answer. Okay, for estimation questions, there are a number of different ways you can do them. I'll show you one way, but don't take this as the only method. There could be different ways of approaching this. So we're measuring the time it takes to make a car in seconds. So we want to work out how many seconds in a day or a year. I'm going to start with a day. So there'd be 24 hours in the day multiplied by 60 minutes multiplied by 60 seconds for every minute. So that's going to be seconds in a day. Then we need to multiply that by 365 to get seconds in a year. And then to work out the number of cars in a year, we need to divide that by 209. So that would take a while to work out on paper. So we'd want to use an estimate to get to a rough answer fairly quickly. So what can we do with these numbers to round them off and make them easier to work with? Well, we could round 24 to 20, and 60, they could stay the same. 360, you could round that to 350 or 400. I'm going to go with 350. And then 209, I think most people would probably round that to 200. And then we could start cancelling some things. So this 20 could cancel with 200. So 20 over 200 would be like 1 over 10. That would be an equivalent fraction. And then we'd have 10 down here, and that could cancel with one of these 10s. So we'd be left with 6 times 60 times 350. So let's write that out. And then that's a slightly easier calculation to do. So this is going to be about 360 times 350. And I'll do a quick long multiplication. Much easier than doing all of that. So 6 times 50, that's 30. 3 times 5, that's 15, plus 3, that's 18. 6 times 3 is 18. Carry the 1, 3 times 3 is 9, plus 1 is 10. Okay, so this is going to be 1,260. And then I need to add on the 2 zeros. So this is going to be 126,000, roughly. Okay. And I wouldn't recommend trying to work out the accurate answer to check if you're close, unless you finish the entire paper and you still have time. So that would be something I would do if I'd leave that question, keep going through the paper, and I'd come back to it if I finished and I had, say, 5-10 minutes at the end. I'd try to work out the actual answer and see if I'm close with my estimate. So anyways, that's my estimate I'll stick with, 126,000. And again, there's different ways of getting to the answer. And I'll just say that the mark scheme gives a range from 100,000 to 200,000. So they're pretty generous with their range of answers for that question. As long as you're showing that you're using reasonable estimates, then I think you should be fine for those 4 marks. Part B says, is your answer to part A an underestimate or an overestimate? Give a reason for your answer. So go back and look at your estimates. I've rounded 365 down to 350 and 24 down to 20, and also 209 down to 200. So mine's definitely going to be an underestimate. So underestimate because of all of the rounding down that I did. So what was it? 24 rounded to 20, 365 was rounded to 350, and 209 rounded to 200. All those values were rounded down. Okay, that's for 1 mark, and question 8 was 5 marks in total. Question 9 says, here's a stem and leaf diagram for the heights in millimeters of 25 seedlings. Work out the interquartile range. Okay, so for the interquartile range, we need the quartile 1, the quartile 3, and then the difference between those. So to work out quartile 1, the method is to take however many things we have. So we'd say that would be n plus 1 and divide by 4. So that's the general formula for quartile 1. So let's do 25 plus 1 divided by 4. That's 26 divided by 4. So that's going to be 6.5, or the 6.5th value. And if we look at our stem and leaf diagram, we need to go to the 6th value and the 7th value, and it'll be the average of those two. So 1, 2, 3, 4, 5, 6, 42, and 42. Well, I've got two 42s, so that makes it easy. These are my 6th and 7th values. The average of those is obviously 42. So that's not too bad. And then quartile 3 is almost the same thing. We do 25 plus 1 times 3 on 4, or 25 plus 1 divided by 4 times 3, however you want to think about that. Or you could just take Q1 and multiply it by 3. So 6.5 times 3, that's going to be 19.5. That value, the 19.5th value. So if we go to, let's count backwards from 25, 24, 23, 22, 21, 20, and 19. So it's going to be in between those two, the average of those two, 19 and 20. And again, they're the same, so it makes it easy. So Q3 is 57, and then the interquartile range is the difference between those two. So 57 take 42, that's going to be 15. So my answer there is 15 millimeters for the interquartile range. Question 10 says, Adam buys a computer, 20% VAT is added to the price of the computer. Adam has to pay a total of £900. Work out the price of the computer before VAT is added. So one way to think about this is we had an original price, we multiplied it by 1.2, which is the same thing as increasing by 20, and this equaled the final price of 900, because it said he paid the total of £900. So to find the original price, we could rearrange this equation. So x is going to be 900 divided by 1.2, which is the same thing as 9,000 divided by 12. Now I find this easy to think about, but if you just want to, do 900 divided by 1.2, that's perfectly fine. Now we could cancel a few things. So I know 3 goes into both. So this is going to be 4, this is going to be 3,000. And then I can see 2 goes into both, so this is going to be 1,500 divided by 2. And I can see that's 750. 15 divided by 2 is 7.5, so 1,500 divided by 2 is 750. Now if you want to jump straight from 9,000 divided by 12 to 750, great. I just find it perhaps quicker to take steps sometimes, so because I can immediately see dividing those by 3 and then by 2. But however you like to do these is fine. So my answer is 750. I'll just show another method, just to, maybe you prefer a different method, who knows. But we could say that 120% equals 900. And then we want to get to 100%. So you could divide by 6. So if I divide 120 by 6, I get to 20%. And then you need to think about 90. 90 divided by 6. Well, I know 60 divided by 6 would be 10. And then 30 divided by 6 would be 5. So that's going to be 15. Therefore, 900 divided by 6 will be 150. And then multiply this by 5. So this is going to be 100% equals 150 multiplied by 5. 500 plus 250, that would be 750. So 2 methods there. Hopefully you find one that you're comfortable with using. And question 10 was for 2 marks. Question 11, part A says solve 3x squared equals 108. Okay, so we need to divide by 3. Therefore, x squared would be 108 divided by 3. Well, I know 3 goes into 90 30 times, and then I need another 18 on top of that. So that's going to be 36. and then take the square root of both sides. So x could be plus or minus 6. Remember that plus or minus, because if we square -6, we still get a positive 36. So my answer there is plus or minus 6. Part B says factorize x squared minus 2x minus 35. So into two brackets, we need to think of the factors of 35 with a difference of 2. 105 and 7 make 35, and we have a -2, so the larger number will be the negative. And we only have an x squared, we don't have a coefficient, so we know that it'll be x and x in the front of the brackets, and then we'll have a 7 and a 5, and this needs to be a negative, the larger number, because we have a -2 in the middle there. And if we expanded those out, we get x squared minus 2x minus 35. So that's my final answer for 2 marks. Part C gives us an equation u equals 3t over 4 plus 2, and part C says make t the subject of the formula. So I would start, t's over here, so I'd start by subtracting that 2 from the left hand side. So we'd get 3t over 4 equals u minus 2. Then multiply by 4, so we'd get 3t equals 4 multiplied by u, take 2, and then divide by 3. So t equals 4 multiplied by u, subtract 2, divided by 3. So my final answer there is t equals 4, blah, blah, blah. Okay, and that was for 3 marks. And question 11 for 7 marks. Question 12, part A says, write down the value of 25 to the power 0. Anything to the power 0 is 1. So that one's not too difficult, unless you're talking about 0 to the power 0. Wonder what that equals. Part B says, find the value of 49 to the power of -1/2. Any negative power means that's 1 over that thing. So this is like 49 to the power of a half, 1 over 49 to the power of a half. And anything to the power of a half is like the square root, that's what that means. So this is the same as 1 over the square root of 49. So this is going to be 1 over 7. And part C says find the value of 64 to the power of 2/3. So this is like the cube root of 64 squared. So another way of writing this is 64 to the power of 1/3, and then squaring that. Now if you have a power of 1/3, that's the same as the cube root. So this is like the cube root of 64 squared. Cube root of 64, what times itself 3 times equals 64? That's going to be 4 squared, which is 16. So the final answer there for 2 marks is 16. And that was question 12 for 5 marks. Question 13 says Ben fills a glass with orange juice and lemonade in the ratio 1:4 by volume. He mixes the liquid that is in the glass. Ben drinks a quarter of this liquid. He then fills the glass using orange juice. Work out the ratio of orange juice to lemonade by volume that is now in the glass. Give your ratio in its simplest form. Okay, so I would love to draw a diagram for this question because I just feel it's going to help my understanding. So he's put orange juice to lemonade in the ratio 1:4. So we have 1/5 orange juice and 4/5 lemonade. And then he's drunk a quarter of that. So we take a quarter away, and that's going to be made up evenly of this same ratio of orange juice and lemonade because he said he mixed it. So this is going to be 1/5 orange juice and 4/5 lemonade in there. And then he filled it up again with orange juice, a quarter orange juice. Okay, so let's work out the ratio of orange juice to lemonade in the remaining liquid. So this is the remaining part in here before he fills it up again. So we need to know the ratio in there. What's the existing ratio in the liquid that's left over? So to do that, we could say, well, we've got 3/4 left over, and the ratio of orange juice to lemonade is still going to be the same, but we want to know the ratio of the entire cup. So for the orange juice left over, in relation to the entire volume of the cup, we've got 1/5 of 3/4. Okay, so this is going to be 3/20, and this was orange juice. And for the lemonade, we've got 4/5 of 3/4. And well, we could cancel the 4's there, so this would be 3/5 lemonade. Okay, so that's the ratios in relation to the volume of the cup. Then we add a quarter orange juice. So we could take this fraction, 3/20, and simply add a quarter to it. So now we're adding fractions, we need the same denominator. So we need to multiply the second fraction by 5. So this is going to be 3/20 plus 5/20 to get that same denominator. Remember, we can't add fractions unless we've got the same denominator. And then we can add the numerators and the denominator stays the same. So that's going to be 8/20 orange juice. Oh, we can simplify that actually. So divide by 4, we'd have 2/5. So we've got 2/5 orange juice now of the entire cup. And lemonade stayed the same. We haven't added or taken away any lemonade. And we've already worked out the ratio of the whole cup that we'd have left. So now we can write the ratio of orange juice to lemonade. And that's going to be 2/5 to 3/5. And you can already see how we could simplify this. We could just cancel out those 5's, or if you like, multiply everything by 5. You'd have the same result. So this is going to be 2 to 3. So my final ratio for orange juice to lemonade will be 2 to 3. And that was question 13 for 3 marks. Question 14 says Aishab walked X miles at 4 miles per hour. She then walked 2x miles at 3 miles per hour. And part A says find Aishab's average speed for the whole journey. Give your answer as a mixed number. Okay, so speed or average speed is going to be the distance traveled divided by the time. So the distance, we know the distance will be 3x, so x miles plus 2x miles, that's going to be 3x. Now what's the time? That's a little bit trickier. So the time is going to be the distance divided by the speed. Now the distance for the first part will be x miles divided by 4. And the speed for the second part will be, let's call these T1 and T2. This is going to be 2x divided by 3. So to find the total time, we could do T1 plus T2, so x over 4 plus 2x over 3. And if we add these together, we need the same denominator, so multiply this one by 3, multiply the second one by 4, that's going to be 8x, and all over 12. And then add the numerators, that's going to be 11x on 12. So my total time for this journey will be 11x on 12. So the speed, going back to my original equation, distance 3x time 11x on 12. And then if I'm dividing by a fraction, I can flip it and multiply. So this is going to be 3x multiplied by 12 on 11x, or 3x on 1, however you like to think about that. And if you look at those two fractions carefully, you can see that we can cancel the x's. So we're left with 3 times 12 as the numerator, so that's going to be 36, divided by 1 times 11, or 11. And then it says to write as a mixed number, so we can't leave it as an improper fraction. How many times does 11 go into 36? Well, 11 times 3 is 33, so this will be 3 and then 3/11ths left over. So my final answer there is going to be 3 and 3/11ths miles per hour for 4 marks. The trickiest part there, I guess, is finding the time to work out that speed. As long as you understand that part, then you should be fine with that question. Part B says the second part of the journey took 25 minutes longer than the first part of the journey. Find the value of x. So we're going to be able to create an equation out of this statement because they've told us two things are equal. So remember the two parts of the journey, we had times for those. So T1 was x over 4, T2 was 2x over 3. Now we need to add on 25 minutes to the first part of the journey because that is 25 minutes less than the second part. So our equation is going to look like 2x 3, the time for the first part, equals x 4 plus 25 minutes. Now this 25 minutes we actually need in hours, not in minutes, because of the speeds they're in miles per hour, we need to keep all of the units consistent. So we need to change this 25 minutes into hours. One way we can do that is to divide by 60 and then simplify that fraction. So divide both by 5. 5 goes into 25 5 times. 5 goes into 60 12 times. So rather than 25 minutes, I could add on 5 over 12 hours. So my equation now is 2x over 3 equals x over 4 plus 5 on 12 hours. So just make sure you're reading that sentence carefully and making sure you're adding the 25 minutes to the right time. Okay, so now we have an equation and we can simplify this and then solve for x. So the first thing I want to do is add these two fractions on the right hand side. So I need the common denominator, which would be 12. So this is going to become 3x over 12 plus 5 over 12. And I'll leave the left hand side the same for now. And then this is going to become 3x plus 5 on 12. And now what I can do to get rid of these denominators is I could cross multiply. So I can multiply this 12 over here, multiply it by the 2x, and multiply this 3 by the 3x plus 5. And what I end up with is 12 times 2x, that'll be 24x. And 3 times 3x is 9x. And I also have to multiply that 3 by the plus 5, so that'll be plus 15. Then I could subtract that 9x from the left-hand side, so 24x minus 9x, that'll be 15x equals 15. And then I'll have x equal to 1. So if we go back to the original question, remember x was the number of miles Aishab walked in the first part of the journey. So she's actually walked 3 miles in total, but all we needed was a value for x there. And what you could do is substitute that 1 back into the original equation to make sure you haven't made any mistakes in this algebra. Okay, so that was part B for 4 marks and question 14 for a total of 8 marks. Question 15 gives us a function fn equals 2n plus 1 squared minus 2n minus 1 squared minus 10, where n is an integer, and it says prove that fn is never a multiple of 8. There are divisibility rules for 8. I'm not sure if they're going to help us here, so I'm just going to start by simplifying this and see what we end up with. So the first thing I want to do is expand out these brackets, and I'm going to write those as double brackets first, and then expand them out. So this is going to be 2n minus 1 times 2n minus 1 minus 10, and then expand them out. So firsts, 4n outers plus 2n, inners plus 2n, and lasts plus 1. And then the same for this one. Remember that a big bracket around all of it so you don't make any mistakes with that negative sign. Firsts, outers, inners, and lasts. Minus 1 times minus 1 is plus 1, and then minus 10 on the end. Okay, and then I will expand this negative to all of the terms in those brackets. So this is going to be 4n squared plus 4n plus 1 minus 4n squared. Minus 2n is minus 4n, and then multiplied by minus 1, so that'll be plus 4n, and then minus 1 minus 10. Okay, so we can cancel a few things here. We've got a plus 4n squared here and a minus 4n squared there, so they'll cancel each other out. And then we have a 4n plus 4n, which will be 8n. And also I've missed the 1s there, so I've got a plus 1 here and a negative 1 there. So they'll cancel out. And then I just have a minus 10 on the end. Okay, so multiples of 8. They could be written as 8 times k, or 8 times any integer, and we're told n is an integer. So a multiple of 8 would have to be 8n. That would be a multiple of 8. So what we've ended up with is 8n minus 10. Now, 8n minus 10 cannot equal 8n. You know, no matter what you do with that negative 10, you're never going to have that equation equaling each other. So we can clearly see this is not going to be a multiple of 8. So I'm just going to say, therefore, fn can never be a multiple of 8. Okay, so that was question 15 for 4 marks. Question 16 says y is inversely proportional to the square of x, y equals 1 when x equals 10. Find the value of y when x equals 5. So whenever you see proportional or inversely proportional, think of this symbol. It's kind of like an alpha. That means proportional to. So we can say y is proportional to 1 on x squared. So that's what it means when it says inversely proportional, 1 on whatever you're talking about here. And then we can make that equal by introducing a variable. So we can say y equals k on x squared, where k has some value that makes these two sides of the equation equal. Now, they've told us when y equals 1, x equals 10. That allows us to substitute those values into the equation and then solve for k. And then we can go ahead and solve for y when x equals 5. So the first thing is we need to find the value of k. So when y equals 1, x equals 10, so this is going to be k on 100. And then, well, we can clearly see if we multiply 100 on the left-hand side, we'll get k equal to 100. And then our equation becomes this one here. We can say when x equals 5, we can say y equals 100 on 5 squared, which is 25. Okay, so I've taken that equation and used it to solve for when x equals 5. And then we can say y equals 4. Okay, so y equals 4, and that was question 16 for 3 marks. Question 17 gives us a diagram, and it says A, B, and C are points on a circle, center 0, center O. CT is the tangent to the circle at C. Prove that angle BAC equals angle BCT. Okay, so BAC is here, and BCT is here. All right, so this is going to involve the double angle formula. So the double angle formula says that if you draw two radiuses or radii from the center of the circle to the circumference, and they have the same arc as these two chords, then the angle at O will be double the angle at A. So we can say that angle BOC equals 2 times the angle BAC due to the double angle formula. And what next? Well, they've told us this is a tangent. CT is a tangent, so that means it meets the radius at 90 degrees. That will come in handy in a minute. We can also say this is an isosceles triangle. So BOC is an isosceles triangle. So triangle BOC is isosceles because these are radii of the same circle. So whenever two sides of a triangle are equal, it must be an isosceles triangle. So therefore, I might use a different color. These two angles, the base angles of the isosceles triangle, must be equal. Okay, so OCB and CBO must be equal. So I'm going to say, I should say that two sides equal length. And then this was BCO and OBC. Angle BCO equals OBC. Base angles of an isosceles triangle. Now it's really important you're giving those reasons for the working out you're showing. So these two angles are equal. Now let's give some labels here. Let's say this was alpha, and so therefore this angle at the center would be 2 alpha. These two angles are equal, as I said, so we could say, using the fact that angles in a triangle need to add up to 180, we could say that, let's give this a label as well. Let's say this is beta, and this is beta as well. So we could say that 2 beta equals 180 minus 2 alpha. Right, so that's that other angle in the triangle. Then, well, we could divide by 2, so therefore beta equals 90 take alpha. And then I can actually make alpha the subject of this equation. So rearrange it so that alpha is by itself. So add it to the other side, take beta from the right hand side. So therefore alpha equals 90 take beta. Now I want to focus on this 90 degree angle in here. I have a beta, and I have some unknown angle that I was looking for. Let's give this another label. Let's call this theta in here. This is BCT. What is theta going to equal? Theta is going to equal 90 take beta as well. Because, as I said before, this must be a 90-degree angle made up of beta and theta. And so alpha equals 90 take beta, theta equals 90 take beta. So therefore, alpha must equal theta. So I'm just going to take this down the bottom and give some of these some reasoning. So this is angles in a triangle, adding up to 180. Then we just divided by 2 and rearranged it. And then we said that the tangent is always 90 degrees to the radius. So therefore, theta equals alpha. So therefore, angle, what were they again? The angles were BAC and BCT. Okay, so that was question 17 for 4 marks. Just want to reiterate again, make sure you're giving some reasoning using the correct language to describe your working out. Okay, question 18 says the graph gives the speed in kilometers per hour of a ship t hours after leaving a port. So here we have a graph with the speed and the time. And part A says find an estimate for the gradient of the graph when t equals 1.3. You must show how you get your answer. Okay, so t equals 1.3. That's going to be, I think these are going up by tenths, so that's going to be here. So let's draw a straight line in to the graph. There we go. And we need the gradient at that point. So to find a gradient from a graph, you need to draw a straight line tangent to that graph of the curve. So I'm going to try to do this as best I can. I don't know how successful I'll be on here, but with a ruler, you can get quite accurate. Okay, that looks pretty good actually. Yeah, looks like it's just touching the graph there. Okay, now we need to try to find the gradient of this line. So one way we can do that is to do the rise over the run. Okay, so this is going to be, pick 2 points on that line that you think you can kind of divide easily. So I'm going to pick this one because it's right on this crosshairs here. And maybe I'll pick this one here, which is on 1. So I know my run is 1, from 1 to 2. And my rise is going to be a bit more complicated. So what is the y-axis going up by? This would be 2.5. What would this be? 0.5, 1, 1.52. So these are going up by 0.5s or halves. So this would be 15.5 to 22.5. So this would be 22.5 up here. So my rise would be 22.5 take 15.5. And my run from 1 to 2 would be 1. Okay, 22.5 take 15.5. That would be 7. So I get a gradient of 7 at t equals 1.3. So I'm just going to show some working out just to make sure I get my full 3 marks. So my gradient will be the rise over the run, which is 22.5 take 15.5, which is 7. And I'm not really sure what else they'd want to see. I think they'd want to see a line on the graph and then some working out to find the gradient for 3 marks. Part B says interpret your answer to part A in the contents of the question. You must give units with your interpretation. Okay, so if we're looking at the speed and the time, this is the rate of increase in the speed. So let's look carefully at this graph a little bit. So when it gets to time equals 2 hours, it hasn't stopped. It's still going at 20 kilometers per hour, but the speed has stopped increasing. So the slope of that tangent 0, meaning it's not accelerating anymore. So it actually starts to slow down. So the tangent is the acceleration of the ship. So the rate of increase in speed. And that's going to be in kilometers per hour, or kilometers per hour squared. So we can say this will be acceleration. So the gradient equals acceleration, or rate of increase in speed in kilometers per hour squared, for 2 marks, and that was question 18 for a total of 5 marks. Question 19 says here are two solid prisms, prism A and prism B, and the cross section of prism A is a sector with angle 45 degrees of a circle of radius 10 centimeters. The prism has a depth of 10 centimeters and a mass of 40 pi grams. The cross section of prism B is a sector with angle 60 degrees of a circle of radius 10 centimeters. The prism has a depth of 5 centimeters and a mass of 50 pi grams. Express the difference in the densities of the two prisms as a percentage of the density of prism A. Okay, so remember when we're looking for density, we need the mass and the volume. So remember this triangle with density and mass and volume. It looks like this. So you've got mass on the top and density and volume on the bottom. So we're looking for density, so this is going to be mass divided by volume. So the first thing I do is write that down. And they've given us everything we need to find the volume of each prism, and they also have given us the mass. So we're going to have to first find the volumes of these in order to find the densities. So the volume of prism A is going to be the area of this sector in here multiplied by the height. So you need to know how to find the area of a sector, so this top bit here, and there's a formula for that. So if you think of a sector as like the fraction of a circle, then it's pretty easy to remember. So I'll just write that over here. Area of a sector is the fraction of the total degrees of the circle. So we could say whatever the angle is, let's call it theta, divided by 360, which is the total degrees in the circle, and multiply that by the area of the circle, which is pi r squared. Okay, so not too complicated. So the volume of A is going to be the area of the sector multiplied by the height of that prism. Just like a cylinder, remember when you find the volume of a cylinder, you take the area of the circle on top, multiply it by the height of the cylinder. Same principle here. So now we just need to substitute everything in and try to solve this. So the angle was 45 on 360. Multiplied by pi, r was 10, so this is going to be times 100, and the height was 10. Okay, let's see if we can do some cancelling here. The first thing I might do is to cancel this 10 with a 10 from the denominator here. So then I've got 45 over 36, and they're both multiples of 9, so this would be 5 over 4 if I divide by 9, or cancel a 9 in the numerator and denominator. And then I have 5 on 4 multiplied by 100. So let me just do a quick note over here so you can see where I'm going with this. Now 100 divided by 4, that's 25. So this would cancel to 25, cancelling with that 4. So then I'd just be left with 5 times 25, which would be 125 pi. And that's centimeters cubed. Okay, so that's the volume of A. Let's do the volume of B now. Again, using that same formula because it's the same type of prism. Take these values, so 60 degrees this time over 360, multiplied by pi. R is the same. Yes, the radius was the same, 100, 10 squared, and the height this time was 5. Okay, now let's see what we can cancel here. Well, 60 over 360, that would be like 1/6. And then I'd have 500 pi as the numerator and 6 as the denominator. So I think that's as far as I'm going to simplify for that one. So volume B is 500 pi on 6 centimeters cubed. Now, don't bother with substituting any value in for pi here. It's going to be easier if you just leave pi as is and leave your answers as 125 pi and 500 pi on 6, because the next step is to find the densities. So the density of A is going to be the mass divided by the volume. So the mass was 40 pi for A, 40 pi divided by 125 pi. Now you can see here those pi's cancel out, so we really didn't have to bother with them. And then I have 40 over 125. if I cancel a 5 in the numerator and denominator, 40 divided by 5 is 8. 125 divided by 5 is 25. So for the density for A, I get 8 on 25 grams per centimeter cubed. And then the density for B is going to be the mass, which was 50 grams, 50 pi grams, divided by the volume, which was 500 pi on 6. Okay, so I'm dividing by a fraction, so I want to flip that around and multiply. So this would be 50 pi times 6 on 500 pi. And again, I can cancel out those pi's there. And also 50 cancels with 500. So 50 would go into 500 10 times. So this would become 6 on 10, which is 3 on 5 in simplest form. And this would be grams per centimeters cubed. So the density of B, 3 on 5 grams per centimeters cubed. Now we haven't finished yet, because remember it said express the difference in the densities as a percentage of the density of prism A. So first we have to find the difference. So we can do that just by subtracting them. So this is going to be, which one's bigger? 8, 3 on 5 is bigger than 8 on 25. So we can do 3 on 5, take 8 on 25. This is going to be 15 on 25. Take 8 on 25, which becomes 7 on 25. So that's the difference. And now I need to express that as a fraction of the density of A. So the density of A is 8 on 25, and the difference is 7 on 25. One way you can find this percentage is to divide the difference by the density of A. So what I mean by that is if we ask, say, what's 3 out of 5 as a percentage, one way you might do that is to do 3 over 5. And you can make that equal to, multiply that by 20. So that'd be 60 over 100. That's one way to do it. Or you could just divide 3 by 5 and get that percentage. So that's the approach I'm going to take here. So this is going to be the difference out of the density of A, and that will give me the percentage. So the difference was 7 on 25 divided by 8 on 25. And if you have the same denominator in each fraction, you can just cancel those out, or think of it as flipping and multiplying the two fractions. Either way, those 25s disappear and I'm just left with 7 over 8. Now I need to change that into a percentage. One way to do it is just to do a long division. I don't know, maybe you have a simpler method, but this is the way that I went with. So divide 7 by 8, and that'll give you some decimal amount which you can change to a percentage. So 8 doesn't go into 7. I'll have 7 left over, so 70 divided by 8, or 8 times 8 is 64, so that's going to be 8 with 6 left over. 8 times 7 is 56 with 4 left over, and then 8 into 40 is 5. So 7 divided by 8 is 0.875. Now to change a decimal into a percentage, we need to multiply by 100. So this is going to be 87.5% for a final answer. Just to go over that again, I think most of this is pretty standard. This is a pretty good method to follow. But once you get to the percentage, changing that into a percentage, I would say, you may have a different method, and that's completely fine. However you want to get from those difference and density to a percentage is fine if you have a way that you're confident and comfortable with. But anyway, that was question 19 for 5 marks. Question 20 says, show that 12 plus the root of 128 over 1 minus the root of 2 can be written in the form a plus b root 2, where a and b are integers. So we have a surd in the denominator. Usually when you have a surd in the denominator, you would rationalize that denominator by multiplying by the conjugate. So the conjugate of 1 minus root 2 is 1 plus root 2. So I'll show you what that looks like. So let's just write that out again and multiply by the conjugate, which is 1 plus root 2 over 1 plus root 2. What this does is to effectively get rid of that surd in the denominator. So let's, I'll leave the top line as is for now. So put those in brackets, which we'll have to expand out. But on the bottom line, if we pretend these are in brackets, we can expand those out. So first is 1, outers is plus root 2, inners is minus root 2, and last is negative 2. So root 2 times root 2 is just 2, and that'll be a negative. So you can see here why we've done that. We've got a plus root 2 and negative root 2, which we can just cancel out. Okay, so all we're left with on the bottom line is a negative 1. On the top line, we'll have 12 times 1, which is 12. 12 times root 2, which is plus 12 root 2, plus root 128, and then root 128 times root 2, which I might just leave as is. You could also write that as the square root of 256, but I don't think that's going to be useful because what we need to end up with is a root 2. So simplifying that now I don't think is going to help in any way. And well, we don't need a fraction anymore. We could just say this is all going to be negative. So if I have just a negative 1 as the denominator, well, that just changes the whole expression into a negative. So now let's try to simplify this a little bit. Remember, we want to end up with a root 2. So have a look at these terms and see if you can change them into a term with a root 2. So 128, this could be written as the square root of 64 times the square root of 2, because remember that the square root of a times the square root of b is the same thing as the square root of ab. So you need to know your index laws or your surds laws for that. The root of 64 is 8, so this would be 8 root 2. And then I could do the same thing there for that root 128. So I'm going to start off with that. I'll leave the rest as is for now. So this is going to be 8 root 2. Now if I change this into 8 root 2, I would have 8 root 2 times root 2. And if I have root 2 times root 2, well, that's just going to be 2. So this last term in these brackets, this just could be written as 16. Okay. Then I might expand out that negative sign. And well, 12 plus 16, that's going to be 28. And 12 root 2 plus 8 root 2, they're like terms, so I can combine them as well. That's going to be 20 root 2. So this is going to be negative 28, take 20 root 2. They were asking for an a plus b root 2, which we have in that form. It doesn't have to be positive. Even though they have a positive here, it doesn't mean the expression has to have a positive. It just means that b is going to be a negative number. So we've got it in the form that they wanted us to put it in, and we can say that a equals minus 28 and b equals minus 20. Okay, and that was question 20 for 4 marks. Question 21 starts off with the diagram, and it says the diagram shows the circle with equation x squared plus y squared equals 100. The unit of length on both axes is 1 centimeter. Circle intersects the positive y-axis at the point A. The point C on the circle has coordinates 6, minus 8. The straight lines A, B, and CB are tangents to the circle. Find the area of quadrilateral ABCO. Okay, so C, they've already labeled that point there. X squared plus y squared equals 10. That means the radius of this circle is 10. So you need to know what that equation for a circle means. This is effectively the radius squared. That tells me point A is going to be at 0, 10. And we're looking for the area of this quadrilateral ABCO. Okay, so this area in here. One point you need to know about tangents of a circle is they're always equal length if they meet up at some point. So you can always draw 2 tangents from a circle. Wherever they meet, that'll be equal length away from the circumference where they join the circle. So I know they're equal length, BC and AB. So I might write that down. So AB equals BC, tangents from a circle, or tangents to a point, I think it's called. The strategy I'm going to take is to split this into 2 triangles. And now these are right angle triangles because the tangent always meets the radius at right angles. Okay, so I just have two right angle triangles. I have the heights of both, so this is the radius as well. They're both 10, and I know they have the same length. I just don't know what that length is. So that's going to be the problem here, is to find this length BC or AB. Now I know there's a way of doing this with Pythagoras. I took a different approach, which I found simpler. I didn't have to deal with any squared terms. You take whichever approach you like. I'm not going to show the Pythagoras way. I'm just going to show the way that I took. And it starts off like this. So you can look at this line OC and you can find the slope of that because you have point C and point O is just OO. So we can find the gradient of OC. So that's going to be the rise over the run, which is just, well, the rise is -8, the run is 6. So it's just going to be -8 on 6. Now, the rule with perpendicular lines is that their slopes are negative reciprocals of each other or negative inverses of each other. So the gradient of CB is just going to be the negative reciprocal of gradient of OC. So I just flip that round and change the sign of it. So it's going to be 6/8. So I know the gradient, therefore I know that the rise and the run of CB needs to equal 6/8. Now because this line is perpendicular to A, I know that B is also something 10. So I know the y coordinate is 10 and I'm looking for that x coordinate. So another way of finding the rise over the run is to subtract the y and the x coordinates. So I can do 10 take -8 divided by x take 6. This needs to equal 6/8. And that's going to allow you to find the x coordinate for B, therefore knowing the length of AB, therefore allowing you to find the area. So this is all the working out you really need to do here. And then you just need to simplify this equation. So this is going to be 18 on x minus 6 equals 6 on 8. 8 times 18, that's going to be 80 plus 64, 144, equals 6x minus 36. So I've just multiplied this over here and 8 by 18 to get rid of the denominators. Add 36 to the other side, so 6x is going to be 180, and then x is going to be 30. Okay, so 180 divided by 6. So going back up to point B, this is going to be 30, 10. So that's what x was, the x coordinate of B. Therefore, the length of AB is 30 because it's parallel to the x-axis. I know the height of that triangle, so I can find the area. It's just going to be the base times the height divided by 2. So the area of triangle, what was the triangle again? It was ABO. Triangle ABO equals the base times the height divided by 2, which is 30 times 10 divided by 2, which is going to be 150, 300 divided by 2. And it was in centimeters, so that's centimeters squared. Now, we know these two triangles are congruent because they have the same angles and the same lengths. I probably should also state that. So triangle ABO is congruent or equals triangle OBC. And this is due to the fact that they have two lengths the same and one angle in between that to be the same. So that would be side angle side rule for congruence. So therefore the area of that quadrilateral, which was ABCO, therefore area of ABCO equals 150 times 2, which equals 300 centimeters squared. 300 centimeters squared, and that was question 21 for 4 marks, and that was the end of the paper. I hope you found that useful. If you did, please leave a like. If you want to see more content, subscribe, and I'll see you in the next one. Bye for now.